My name is Mauricio Vélez from Neurotech UCB from La Paz, Bolivia.
Hi, my name is Jenny. I am part of EVISS UCB and I am a member of the hardware team.
Hi, my name is Fernanda. I am part Neurotech UCB. I am a member of social media team.
Hi, my name is Belen. I am part of Neurotech UCB and I am a member of hardware team.
Current advancements in neuroscience and technology in general are helping us to be able to achieve landmarks previously so impossible, for example.
The capacity to take a human to the moon, treatment for various diseases among others. Our project today aims to help a specific sector of injured people, paralyzed people, people that are unable to move their limbs freely and regulate to sitting or lying down all day. The end user for this project interacts with the system through two distinct systems: webcam that detects head movement and an EEG that detects alpha waves.
Now for the EEG part of the project. For this part, we actually use equipment from our sponsors, OpenBCI, two in concrete. One, the OpenBCI Cyton board, and two, the EEG electro cap. From the Cyton board, we connected 4 channels to the cap. The 4 electrodes were the O1, O2, P3, and P4, following the 1020 system, registered in the occipital region of the brain, where alpha waves for action like closing your eyes are best detected. Alpha waves, which range from 8 to 30 Hz, are easily detected when someone closes their eyes. This allows for easy training of the end user, since this part of the project will focus on an emergency system.
Other feature that the project has is the facial recognition. The same devices that processes the information will also handle the facial recognition to activate or deactivate the security system. It shows artificial vision using a model which is called hard cascade ACE from EVISS to recognize a position. The end user must incline their head towards the right to activate or deactivate the security, and the user can move their head to deactivate the system. The heart of the scale model plays on the Raspberry Pi. The board handles all 3 sensors incorporated on the scale model, as well as a camera, a display screen, and finally a Telegram bot created to send the alarm detections to a family member in charge of the person's care.
As we mentioned before, we have here the 3 sensors installed in this little house, where you can see here the metal sensor. Here you can see the peer, which is the presence sensor, and this is the temperature sensor. Here we can see also the display, where we will see the message that will be sent by the Cyton signals and vision artificial signals. We also have the camera, who's in charge to receive a person presence in the house, and that will try into.
Okay, so as we can see in my laptop, we have the program already running. The webcam is already recording in real time, and also I have the equipment already installed. So we're gonna move to our left and turn the system off. Then we turn to the right, and the system is turned on. After that, to detect an alpha signal, we just close our eyes, and as we can see, the 3s that it has detected the alpha waves and it has sent the signal.
To see how it is reacting, we can see here the emergence signal that is emitted by Cyton, and here you can see the message that it gets saying that there are an alarm activated emergency. This is through Telegram bot, and all the system is not loading now because the emergency is working. But now we're gonna active again, and we can see here the alarm system activated. Now the alarm is activated, we can see and perturb and create some perturbance here to see the person is detected, and here you can see that movement is detected in the room. And we're also gonna touch the sensor metal. That will be saying also that, as you can see here, the window sensor is detected, which is in charge of metal sensor, and it will be sent that there are movement detected in the kitchen. Now we're gonna see the camera.
Now we will also test the camera body detection, in which Belen will approach the camera, and then a notification will be sent that says house alarm body detected. Okay, so on this part, I'll explain a little bit further what is the code that we use on the laptop that makes the connection between the board and that sends the signals to the Raspberry Pi. So to start, we need all these libraries to proceed with our project. We also need this pre-trained model known as Cascade, i3 eyeglasses. This model actually uses eye detection even if you have your eyeglasses on. Also, we need to start the video capture. We need to declare it even before we start it, and a couple of counters that we use in the future of this code. We start the socket. We have this IP address for the RASP, and we also set the board and the port for the site-on-board communication. Also, to do the processing, we declare the alpha band. We're going to use a bandpass filter, so this is going to be needed. And we know that alpha waves are actually detected between 8 Hz and 13 Hz. So this is the explanation for the numbers. Also, we declare the sampling frequency. Alright, so we declare both functions. The first one being socket, in which we send through TCP type connection over Wi-Fi from our laptop to the Raspberry Pi. And the second function, detect alpha waves, is basically a bandpass filter that uses the library SciPy to grab all the data from each electrode, filter it through a bandpass filter, and get the mean from all the data and from all the process data, and we also return it to the main function, or well, to the main program. For the parameters, we declare them here. With board, we prepare the session, and here we start the stream. Here we declare the electrodes. That is the first 4. That is actually the connections we're using in the Cyton. And this is our loop, in which is going to be iterated until we declare it otherwise. The first part, as it is shown, it declares and actually works with the computer vision part of the project, in which we use a frame that detects from the webcam. It does a compression from BGR to gray, and it goes to detect the eyes on said image. And then it goes through all the detected eyes and determines the position of the look. Depending on this position, whether it's up front, left, right, or unknown, it will actually do certain condition. Inside these conditionals, we have this send through socket that it is for both left and right. So if left is declared, we use a flag to say that it's 0. And if it's 1, we'll set it to 2. This with the aim that it only sends this number once. So it's just going to send it once, it's going to put it to 0, and then it's going to enter again if the person continues to look at the left side, and it's not going to keep sending constantly. So we have the same logic for the right side, and to unknown we do nothing, and to upfront nothing as well. Then this is the basically the showing of what the webcam catches, and with a couple of legends such as gaze direction, and gaze detection. And to kill that window and actually kill the program, we actually just have to press the letter Q, and that's it. And this is the part actually directed towards site and communication. So we get the connection up and before and during the program, but during the loop we constantly get the data from the board, and from said data board we actually just use the first 4 cables used to connect to the electrodes that we already declared. Now we have 2 loops for each electrode that we're going to use. On the first one, we actually create a list in which we append each alpha power from each electrode detected. Then we print the maximum at the end, and then for the second cycle, we detect if these electrodes pass through what is the threshold, and if they pass, the counter just increases, and if we reach a number, the socket will actually send through Wi-Fi the number 3, and that will activate the emergency system. And finally, this last line of code is just to release the resources. We close the socket, we stop the stream, we release the session, and we basically destroy all windows that are related to computer vision.